Hi folks, welcome to Maths and Physics for You. Today we will continue with our lessons. This time will be about the trigonometric difference formula. This is called Atwani's formula of trigonometric difference identity. We know that there are so many trigonometric identities. The most famous one is the cosine square theta plus sine square theta equals 1. This is the basic one, based on the unit circle, where cosine square theta plus sine square theta equals to 1, and based on Pythagoras theorem. Now, the formula here that has been developed by Atwani is called Atwani's formula for trigonometric difference, and this is cosine square theta minus sine square theta. That's what we're going to show here, equals what? This is an expression in terms of trigonometry, but also it was developed further so that in certain situations in engineering, in structural design, electrical engineering, and other fields of engineering, it would be very useful also to show this difference not just in terms of a trigonometric function, but as a power series. Okay, so we started with the first steps. As we know here, that cosine square theta plus sine square theta equals to 1. So if we rearrange this formula here, cosine square theta, we sub sine square theta. We know sine square theta from here equal to 1 minus cosine square theta. Sine square theta equals 1 minus cosine square theta. We move cosine square theta to the right hand side. So sine square theta equals 1 minus cosine square theta. We replace it here. We sub it here, as we can see. This is equation 2. Sub 2 in equation 1. Let's call this 1. So by summing or substituting, so we get cosine square theta minus, instead of sine square theta, we put 1 minus cosine square theta, which is this one. This expression is put here. So this expression for the difference, cosine square theta minus sine square theta, becomes like this. Now we expand here, so you get cosine square theta, minus times minus is plus, so plus cosine square theta minus 1. Now we're adding cosine square theta plus cosine square theta, that gives you 2 cosine square theta minus 1. So this expression at the top has been transformed into 2 cosine square theta minus 1. But to be more useful, we make use of other relations, trigonometric relations. We know that the sum formula for cosine goes theta 1 plus theta 2. This is sometimes referred to as the sum formula, the sum of two angles. So that's equal to cos theta 1 cos theta 2 minus sin theta 1 sin theta 2. So here it's minus. You subtract. Whereas the cosine of the difference is the difference formula. Cos theta 1 minus theta 2. The same thing like here, but we have a plus. Now, to simplify, we add both these expressions, the sum formula and the difference formula. As you can see, these two we cancel out. So this expression and this expression, they will cancel out. So we are left with 2 cosine theta 1 cosine theta 2. These two expressions are the same. So we have cos theta 1 plus theta 2 plus cos theta 1 minus theta 2 equals to double this expression. Alright, that's great. Now, we put the special case. Let's have two angles are equal. Let's say x equals y, or theta 1 equals theta 2. And we call it equals theta, let's say. So what will happen here? This becomes cos 2 theta. They are equal. They become cos 2 theta. Now here you put theta minus theta is 0. So you got cos 0 equals to 2 cos theta times cos theta, so 2 cosine square theta. But we know that cos 0 equals what? Equals 1. Good. So by substituting here, we had cos 2 theta plus 1. Cos 2 theta plus 1 equals 2 cos square theta. Alright? Now, we continue here. If we move 1 to this side, it becomes 2 cosine square theta minus 1. 2 cosine square minus 1 equals cos 2 theta. So cos 2 theta, you bring the 1 to this side, you get 2 cosine square theta minus 1. But this is what we got before. So this is what we wanted to simplify. For the difference, for Atwani's difference formula. This is what was found. So by putting this in that formula, 2 cosine square theta minus 1 equal to cos 2 theta in the original equation 1. So we get cos square theta minus sine square theta equal to 2 cosine square theta minus 1, but this will be equal to cos 2 theta. And this is the conclusion. So the trigonometric formula, Atwani's trigonometric formula here for the difference will be given by cos square theta minus sine square theta equals to cos 2 theta, which is concluded here. Okay, next we will show how also this has been related to power series. So we continue now with the Atwani's formula that has been found in terms of trigonometric expression. That is cosine square theta minus sine square theta equal to cos 2 theta. But further, it has been developed further in terms of power series. Like we know by plotting the graph of cos theta, the angle theta, it looks like this. So its maximum value is plus 1, its minimum value is minus 1. So it's a wave function that oscillates between minus 1 and plus 1. So this gave thought to another expression for this difference in terms of power series. So the easiest thing to think about is that it should be 1 minus something. So this was like a starting point of development of the power series expression. And Atwani has used many iterations, 1 minus something, and then adding and subtracting, adding, subtracting, and finally obtained an expression which is given very similar to what other researchers also found, like Maclaurin and Taylor's, who developed their series. So what we got here is that if we start with the simplest form, that is for cosine theta, that gives us the expression that cos theta equals, as it is starting from plus 1, so it's 1 minus, plus has to be minus, plus, and so on. So that way of experimentation give rise to theta square over 2 times theta 4 over 4 times 3 times 2 minus theta 6. Now we notice here that with these experiments that 4 times 3 times 2 is the factorial for 4. So the same thing for this, the following expression. So that was theta 6 over 6 factorial, and the pattern was noticed. So it keeps going like that, plus theta 8 over 8 factorial minus theta 10 over 10, and so on. So as the number, so this gives you closer and closer approximation to the trigonometric expression as the number n, let's call it, the number of terms becomes bigger and bigger and closer to infinity. So these two functions, they become equivalent. So that is cos theta is given in terms of theta as a power series, but as we mentioned, Maclaurin also developed using Taylor's power series and principles of power series to develop a similar expression, which is also given here. It has been compared and very similar. So cos x equals to all this, as we can see it here. Okay, and we can see now by continuing with cosine theta has to be between -1 and +1, as we saw in the graph, and with the expression oscillating between minus and +1 with so many iterations and trial and experiments. This is the expression. So cosine theta equals -1 plus theta squared 2 factorial minus theta 4 factorial, and so on. As you can see, this is a pattern. It was found that this looks like a pattern. So this is 2 over 2 factorial, 4 over 4 factorial, and so on. And the larger the value of 8, as we keep going, the closer the expression is. Okay, but here in the difference formula we have 2 theta. So all what we have has been done is to sub 2 theta for theta. So now we will have cosine squared theta minus sine squared theta. Cosine squared theta minus sine squared theta equals to cosine 2 theta. That will be, by subbing here, replacing theta with 2 theta, you get -1 plus 2 theta squared over 2 factorial minus 2 theta 4 over 4 factorial, and so on. So this is the conclusion, that the Atwani's formula of trigonometric difference identity, we got it in terms of a trigonometric expression, that is cosine squared theta minus sine squared theta equal to cos theta 2 theta, and in terms of power series, it's the summation from k equal to 0 to infinity, minus 1 to the power k, 2 theta to the power 2k over 2k factorial. So if you sub this, you get this formula. And there you have it, folks. Thanks for watching. Please subscribe, and see you in the following videos.